Hello everyone, so let's look at some precipitation reactions and specifically at the idea of fractional precipitation, which is where you have a mixture of ions and then you use the addition of a different species, a different ion to uh, separate those ions specifically, so meaning fractionally remove them from solution using their solubility to your advantage. So we're going to investigate how we can do that. So this example says a solution contains 0.001 molar in each of chlorine, bromine, and iodine. So meaning each of those halide ions have a concentration of 0.001 molar. And then it says we add silver nitrate to the solution to precipitate each of these ions from solution. So at what concentration of silver plus will each of the salts begin to precipitate, and in what order will the salts precipitate, given the following information? So as you can see, the salts that will precipitate is silver chloride, silver bromide, and silver iodide, and they have different KSPs, differing by about quite a number of orders of magnitude, about 3 orders of magnitude each time, or at least 6 orders of magnitude in the case of the chlorine and the iodide salts. So the idea here is that each of these salts will, of course, won't precipitate at the same time. So meaning one of them will precipitate first, and then we'll be able to remove that salt first. And hence we have removed the that ion that salt contains alone. And so we now have the ion that salt contains on its own. And then we can remove the next ion and the third ion. So we've separated the mixture that contained chlorine, bromine, and iodine. We actually now have 3 different salts that only contain chlorine, bromine, and iodine. All right, and that's why we fractionally precipitate each of these, and so hence we've actually been able to separate a mixture from its different constituents. All right. Now the general idea here is that we have a metal or a silver halide salt, right, which exists in some equilibrium, some aqueous equilibrium, with the silver plus and the halide anion, right? X is the halide anion. So X minus, or X is Cl minus, or Br minus, or I minus. And each of these have a KSP. So the KSP expression for them will be silver plus multiplied by X minus, where X is of course the halide. And we know from the information given that in each case the halide ion concentration is 0.0010 molar. The question is, at what concentration of silver plus will a precipitate fall? And hopefully you see that the different KSP values will of course dictate that different concentrations of silver plus will cause a precipitate to fall. All right. So we can use the KSP values to solve for the silver ion concentration given the same concentration of the halide ions in each case. Alright, so let's go ahead and do that. And because it's the same idea over and over, I've just skipped ahead and I've written that out for us over here. So we can just move it a bit to the top. so we can discuss it. Well, trying to keep some of the things in frame. Okay, we can't really, but that's okay. So what we go ahead and do is to precipitate silver iodide. We of course use the KSP of silver iodide. Oops, let's see, it needs a head. Silver iodide, and we divide by the iodine concentration. For silver bromide, we use the KSP of silver bromide. For silver chloride, the KSP of silver chloride. And in each case, the halide concentration is that 0.001 naught, right? So that's what we do. And then we calculate the concentration of the silver ion that we need to force a precipitate to form. And as you can see, they differ, in each case, because the KSP differs in each case. And then from there on, so now you've calculated that, what we see there is that the salt that needs the lowest concentration of silver plus is iodide, the silver iodide. The salt that needs the second lowest concentration of silver plus is silver bromide. And the salt that needs the highest, or the lowest concentration of silver, or the highest concentration of silver to precipitate, is silver chloride. So that means, in principle, the salt that precipitates the easiest, in other words, the salt that requires the lowest concentration, is the salt that will precipitate first. And that is silver iodide, will precipitate first because it requires the lowest concentration of silver plus. That will be followed then by silver bromide because it has the value in the middle. And that's finally then followed by silver chloride, which requires the highest concentration or the highest amount of silver iodide, silver plus concentration to precipitate. All right, and that's the basic idea. And so we are able to remove these each separately, because once this has precipitated, then you can remove the precipitate, right? So you can then take this out, move it aside, take it out of the solution, and then your solution only contains bromine and chlorine, right? So then you can add, so now you've removed the silver iodide because it's a precipitate, so take it out of the beaker. Now you have some silver iodide, you dry it on the side, you actually filter it through a Bachner funnel, but I don't think you have reference for that at the moment. And then you can work onto the next one. Get that precipitate, filter it off, move on to the next precipitate, and then finally remove that one. And so you've actually removed all three precipitates, and you have them in a pure or relatively pure form. They won't be exactly pure, but you'll have them relatively very high purity. Alright, and that's the main idea here, is you can use the KSP value to determine the concentration needed to precipitate these. Alright, and then you can fractionally precipitate them, meaning precipitate the one after the other. Alright, because the one needs a different concentration to the other. So this one will precipitate first, followed by that one, followed by that one. Alright, good. Thank you for watching, and I'll see you in the next video.